Here, I won't try to make this pretty brief so you get a little time to work on some things too. Today we're gonna take a small step forward here. We're gonna talk about linear inequalities instead of equations, right? So there's not much difference between an inequality and an equation. In fact, I mean the only difference when I write an inequality, the only difference is we're just using an inequality symbol instead of an equation. But what does that mean in terms of the solution set and the graphs, right? That's really what we want to look at today, is how do we graph these things? That's sort of our big project for the day, is to learn how to graph inequalities, okay? So first of all, how about what's it mean to be a solution? It says determine which points satisfy the inequality. In other words, which of these points are solutions, right? Well, solutions for an inequality work in the same way that they do for an equation, right? If I have a linear equation here, how could you check to see if, for example, the point 4, 3 is a solution? Plug it in, see if it works, see if it satisfies the equation. If it satisfies the equation, that means it makes it what? What's it do for the equation if it satisfies it? Makes it true. Good. Let's get rid of your buds and all that stuff. Okay, so we plug it in, we see what happens. If we plug in the ordered pair 4, 3, I'm going to get 2 times 4 plus 3 times 3. And the question is, does that equal 17? It does. I get 8 plus 3, or 8 plus 9, which is 17. So yeah, it's a solution, right? That one works. Okay. What does it mean to be a solution of an inequality? Well, the same thing. We're just going to plug in the ordered pair. We're going to evaluate the inequality at that ordered pair and see if it makes a true statement. If it's a true statement, then it's a solution. It satisfies the inequality. If it's not a true statement, it's false and it's not a solution. Right, so what about this guy here, 7, 4? If we plug those points in, what am I going to get if I plug those into my inequality? So I'm going to get, what's going to be on the left side of the inequality? 4. Okay, so I get 4 is greater than or equal to negative 2 times good plus 9. And we put a little question mark there over the top to see if it's going to work, right? We still don't know. So what's this give us over here then? I get negative 14 plus 9, which is what? Negative 5. Is that a true statement or not? Is 4 greater than or equal to negative 5? It is, isn't it? Yeah, 4 is greater than or equals greater than. So that is true, and the answer is yes, right? How about this next one? Let's try this one here. So if I plug in the point negative 1, 3, I'm just going to get 3 is greater than or equal to negative 2 times negative 1 plus 9. That's pretty obviously going to be false, isn't it? Right? Does that make sense? I'm going to get 3 is greater than, that's positive 2 plus 9. Is 3 greater than or equal to 11? No, it's not. So that's not true. The answer is no, right? And so on. We can check a bunch of them. That's all we're doing. We're just plugging in the points and seeing if it makes a true inequality or not. Okay, why are inequalities, I mean, why do we talk about it? Well, I mean, they're sometimes useful. Sometimes they match situations better than equations do. Like what about this one? John sells t-shirts. Plain shirts cost $5 and graphic shirts cost $7. In order to match his product costs, he must make at least, and there's the important wording, he must make at least $1,200. So how much money could he make?
1,200 or greater.
1,200 or greater, right? He can make 1,200 or he can make 1,300, but he's got to make at least 1,200. It's not going to hurt his feelings if he makes 1,500. That's probably a good thing, but he's got to make at least 1,200, right? So there's no one answer to how much he can make here. There's a whole infinite number of possibilities, but there's a lower limit, right? So that fits with an inequality rather than an equation, right? If we want to set this up, if we want to write an inequality, let's try doing that. So what's an expression that's going to tell us how much money he's making? If the plain shirts cost $5, what do you think?
1,200 is greater than or equal to 5x plus 7y.
Okay, so and you're saying, let's define what x is. So x is what then?
Amount of plain shirts.
Okay, number of plain shirts. And then Y must be number of graphic shirts? Okay, so then, let's first of all, let's just take the expression that's gonna tell us how much money he's making. So we're not gonna put anything, we're not doing an equation or inequality yet, we're just gonna make what's gonna be on one side of the inequality. What's the expression that tells us, when I say expression in math, that means a sentence is like an equation, an expression is like an expression, right? It's like a phrase or something. There's no period, there's no verb like it would be in a sentence, it's just saying the blue dog or something like that. I want the blue dog, the blue car, right? We're not gonna say a complete sentence, we're just saying a part of it. That makes sense, right? How are we gonna turn this stuff into amount of money that he's making? Say it again, it's gonna be.
1,200 is.
Well, forget about the 1,200 for just a second. How much money is, that's gonna be what we're gonna compare it to, but what's the amount of money we're gonna get from just the plain shirts or the graphic shirts? How much money do we make from the plain shirts? 5x, right? Good, so 5x plus 7y is how much we're making from the graphic shirts, right? Now, how are we gonna compare that to the 1,200? The amount of money we're making has to be greater than or equal to, there you go, okay? Has to be at least 1,200, so it has to be greater than or equal to 1,200. Okay, make sense? Okay, so then what if how could we tell if this is gonna work? If he sells 150 plain shirts and 60 graphic shirts, will he be able to cover the product cost? Plug it in, right? All we're doing here is we're just evaluating this inequality at the ordered pair, 150, 60, aren't we? Right? We can see if it works. So if I plug that in, I'm gonna get 5 times 150 plus 7 times 60. And what does that equal to? 750 plus 420 is 1170. So that's gonna equal 1170. Is that greater than or equal to 1,200? 1170? It's not, is it? Right? So that's not a solution. Does it cover his costs? No, it doesn't, right? Doesn't make it. What about this other part then? If he sells 90 graphic shirts, what's the minimum number of plain shirts he must sell to break even? So we're trying to solve for what variable then? X, yeah, good. This is asking what's X, right? What's X gotta be? So we would just start with our original inequality. 5x plus 7y is greater than or equal to 1,200. And what are we plugging in?
90 for Y.
90 for y, okay? Or, yeah, 90 for y, exactly. So we're gonna get 5x plus 7 times 90 has to be greater than or equal to 1,200. Well, look, now there's only an x left, right? So all I gotta do if I wanna solve for x is isolate it.
Wouldn't you want it just to be equal to because you're breaking even?
I mean, I could see that interpretation. I mean, we could just maybe do the equals. It's saying what's the minimum number. When we're all done, you tell me what you interpret this for me. Okay, I know what you're saying, though, and I get that. That's a good point. Okay, so then 7 times 90 is what? What's 7 times 9?
630.
It would be 63 plus a 0, wouldn't it? So 630 greater than or equal to 1,200. What are the two steps to isolate x? Subtract 630, divide by 5. And we get 5x is greater than or equal to 570, I heard it. And then last step was divide by 5. And so I'm going to get x is greater than or equal to 114. Okay, so what's that mean? X is greater than or equal to 114.
That's what X has to be with the minimum amount.
Good, it has to be at least 114, doesn't it? He could sell more plain shirts than that, but he's got to sell at least 114 shirts to break even if he's selling 90 graphic shirts, right? Make sense? Okay? All right, so last issue then for today is let's talk about how we could graph these things. Super easy, it's no big deal. This is really no harder than just graphing a line. There's only one extra step, and that's it. So all we're gonna do here is, when we're graphing an inequality, think what this is saying here. Before we even start on this, just contemplate what this is saying. If this were an equation, it's saying y is equal to 2/3 x minus 1. That's just in slope-intercept form, right? So y equals mx plus b. What's this saying, though? This is saying something different. This is saying y is less than mx plus b, right? Now, what do you think that means? I'm going to have this line, right? We know that the line y equals 2/3 x minus 1 is the boundary line. But I only want all the stuff in the xy plane that's where y is less than that line. Y is a vertical variable, right? So what do you think it means for y to be less than something? Below it, yeah. Vertically, it's going to be the stuff that's lesser values vertically means below, doesn't it? Right? So what do you think this is going to look like then, if I graph this? We're going to shade everything below the boundary line, okay? Right? You might remember doing this a little bit, right? So then, let me ask you this. Are we including the boundary line this time? How's that launch? Is that pretty good?
Yeah, that's pretty good. Thank you.
So are we including the boundary line this time?
No.
We're not, are we? Because it doesn't say less than or equal to. It just says less than, right? If it said less than or equal to, then we'd be including all the stuff below or the line itself, correct? But this time we're not. This time we're only saying the stuff below. So what that means then is, when we graph this line, we're going to use a dashed line if we don't have an equal sign included in our inequality. You probably remember this stuff from Algebra 1, right? So that means it's just a boundary, but it's not included. Okay, so let's graph the line. We can do that. It's in slope-intercept form. What's my y-intercept? What's my slope? So we ought to be able to get this then. Where do we start with our boundary line? -1. Okay, and what are we going to do from there? Good, up to and right or over by 3. Good, and that gives us a second point. And then we're just going to connect and extend with our dashed boundary line, right? Now, which one are we going to shade? Well, if we're doing y is less than the boundary line, we're shading below, aren't we? Right? So we just do this. That's our solution. Okay, make sense? Okay. So the first step is, just like we did when we graphed lines, we just put them in slope-intercept form to graph them, so then they're easy to graph, right? Okay, so let's try one more of these. Let's try, that's an easy one, let's try that one. So what is, I kind of already have a little bit of it done. What's the boundary line look like? What's the line x equals 3? There it is, vertical line, right, going through x equals 3. Already done. Now, which side am I going to shade this time? Because this time we don't have a y value. Okay, but I'm picking the x values that are greater than the line. X is horizontal. Horizontally, what's greater and what's lesser? Greater is that way, lesser is that way, right? So all I would do here is shade all I have to do here is just shade that stuff, right? And the boundary line this time is solid because I'm including the line. It's greater than or equal to, right? Okay, how about, we'll skip up and do this one. First step. We've got to be able to graph the line, the boundary line. So what form do we want to put it in? Slope-intercept. Okay. So what are the steps to put this in slope-intercept? Nancy, what do we do first? Slope-intercept means I just got to isolate the y, right? So what am I going to do to get that y by itself? Good, subtract 5x. Very good. So we're going to subtract 5x from both sides. And that's going to give us 3y is less than or equal to, let's put the 5x first so it looks like mx plus b. So we get negative 5x plus 12. What's next? Divide by 3. We divide everything by 3. What am I going to get over here? What? Y Negative over positive is negative, and can I simplify 5/3? No. Question, Tyler? Yeah. So I get negative 5/3 x, and what's 12 over 3? Okay, so there's my boundary line, right? I put it in slope-intercept form. Now I gotta be a little bit careful here, because what if that had been like 5 minus 3y? If I divide both sides by a negative, what would I have to do? Flip the inequality, so you gotta be a little bit careful about that, right? So now our boundary line, where do we start? 4. So up 1, 2, 3, 4. Okay, Jaylene, what am I gonna do from there? My slope is negative 5/3, right?
Yeah.
So what do I do to get my other point? How do I use a slope triangle? I go,
Down 5.
good, go down 5 and right by 4. And that gives me a 3. Oh, sorry, 3. So there's another point. Solid or dashed line?
Solid.
Solid, good. And last issue then. Am I shading above or below? Good, shading below, aren't I? Because look, I've got a y is less than, correct? Yeah, so I'm shading below the line. And so, everybody agree this is my, that's what it looks like?
Seems reasonable to me.
Okay? We good?
I think we're great.
Okay, I'm done. You may work, I'll put that assignment up, but it's, you may or may not be ready for that yet.